I'm Robert Bobbitt. I'm the the Executive Vice President of Sales and Marketing with FP Complete. And I want to thank you all for coming out here today. And I know it's the day after the fourth holiday, so not sure if that was a good strategy or not, having it the day after, but kind of split, the room split on that. But we have a good lineup today. I'm going to have John come up here in a moment. We're co-sponsored this event with MindCentric, and John will explain, how the relationship between our two companies. And of course, our guest speaker, Erin will be up after that, and hopefully by that time, the food will be out in front of you. You can just sit back and relax and listen to the conversation. So. And there'll be Q&A after. Yeah, the agenda is pretty simple. We're just doing a short introduction from MindCentric. Erin will be doing the conversation, and I encourage you, of course, to stay afterwards and talk with Erin, ask questions about what we spoke about today. So, John, you want to kick it off here?
All right. Well, thank you everyone for coming. I'm just going to take a few minutes to introduce our company. Quick show of hands: how many people are actually in a DevOps role or in DevOps management? Sort of. Well, great. I wanted to share with you a real quick story that's kind of fitting to the topic. Went on a ski trip with my kids, and there was 4 families there. 2 of the families I didn't know, and we were in the basement shooting pool with one of the guys, and we started talking. I'm like, "So, what do you do for a living?" He goes, "Oh, I'm in DevOps." I'm like, "Interesting." I go, "How'd you get into that role?" He goes, "Well, somebody said if I wanted to advance my career in software, I should get into DevOps." And I said, "Well, how's it going?" He goes, "Well, I'll tell you in a few weeks because we're migrating everything to AWS." And he goes, "I haven't been sleeping at all, but it's been very stressful." And I said, "Well, have you had any experience doing that type of thing?" He's like, "No, but we're learning along the way." And I said, "Well, what if you had resources or a company that had actual experience in doing that and lived and breathed that every day?" He goes, "Would that be useful to you?" He goes, "Well, yeah, that'd be great." I said, "Well, that's what my company does." He goes, "Well, I didn't even know people like you exist." So a month later, I'm at this charity thing for our school, and I said, "Hey, how did your migration go?" He goes, "Well, get a beer. Let's go talk about it." He said, "We cut over on Friday. Everything's going good. Monday afternoon, everything just stops running." And he's like, "I think I just killed our company. I think I killed my career." So they all buckled down, and in a few hours they got things back and running, but it took them about a week, everybody working 24/7 to get things back running again, and eventually they did. And he goes, "The whole time I was thinking about you," and he goes, "I wish I would have had some help through this process." So we're here to kind of talk, that's what we're kind of here to talk about. And what we talk about on this slide here is we want to enable the DevOps and DevOps managers to take ownership of their projects. And what we're here to do is give you guys resources to fill voids where you have in your companies and be a resource to you, so that a lot of this stuff may be new, because when you're in the DevOps role, you're typically coming from one side, and not everybody's going to know everything about all these things. So we're trying to be that resource to you. And again, you own that relationship, you manage it. What MindCentric does is we're doing operational tasks. We manage things. Since '99, we've been managing infrastructure and data centers and supporting applications. All of our customers own their application and run that, and we fill those voids for them. Then we're working with FP Complete. They're very complementary to what we do because they automate that process. They help you push the code out. And there's a lot of synergies in how we all flow together. So that's where we want to bring this together for you as an organization and bring those resources to mind. Real quickly, so we kind of talk about, we're going to be talking about just real quickly what we do in the services area. We're also a cloud provider. We own and operate all of our infrastructure out of the SuperNAP facility and Switch. We're also partners with AWS and Azure. So we integrate, we merge, we do hybrid clouds. And we've been doing that since '99. We've been doing Office for the last 5 years just out of customer demand. We kind of try to stay away from that. And that's really how we differentiate ourselves, because a lot of people think of IT services as kind of a desktop company, and we're just the opposite. We avoided that for a long time, and now with the convergence to the cloud, it's kind of made sense for us to adopt that. I know there's a lot of words here, but just wanted to highlight a few things. We've been in business since '99. We were a software development firm back when we started, and we got into managed services out of our customers wanting us to manage things. And over time, we just kind of evolved into that business. But I mention that because we've got that software background, and we've developed our own, what we call our own toolbox, that does a lot of monitoring and automation from the management side. And we've built those tools understanding how to help support applications from a management standpoint. And we've got 10 years plus of experience running virtualization and cloud. We've done hundreds of migrations, physical to virtual, in and out of clouds. Like I mentioned, we're an owner-operator. And this is kind of what we're here to talk about is where's your core business? And I like to use the term core versus chore. IT chores are things that you can look at outsourcing and getting help on. We want our customers to focus on their core business because that's what makes you money. The more effort you can put into that, developing apps, features, and functions that generate revenue for you, and if you can outsource operational things, then that can make you a lot more efficient. And I highlighted this down here in red because what we do when a lot of times companies think, well, I got to do everything. We scope our services so we can help you as much or as little as needed. So it could be a small little task that needs like help with architecture or security, compliance, and then we scope everything to your needs. So we try to just fit where it makes sense with your existing staff, with your budget, and your needs, and help you focus as much of that on your core business as possible. And that's just it in a nutshell. I think that's all. Oh, this is just a really quick slide of talking about different verticals we do, some things of how we've helped companies. One day we were sitting around talking about all of our customers that have been acquired, and we started adding it up. And it totaled over $1 billion in acquisitions that our customers have experienced. And this kind of focuses on a few highlights. So the red is the company that did the acquiring. The green was our customer who we helped go through that acquisition. And it's kind of a fun little fact that we're kind of proud of. But that's all I have, and I'll turn it over to Erin.
Well, let me just take a quick second here. So, and you can contact John here. I will be making a copy of this presentation available to everybody, so no fear there. Just a quick introduction for Erin. Erin started FP Complete about 5 years ago. FP stands for Functional Programming, which, if you're not familiar with that phrase, it's just what we call the next generation of programming. Erin basically started the company because, quite frankly, is frustrated watching everybody do things in a really inefficient way. And that's really what this whole DevOps conversation is about. How do we do things a lot more efficiently, and what kind of changes do we need to make to move in that direction? So, as you'll see, Erin will talk a lot about some of his experience. He worked with some big companies. You all know Microsoft and Bill Gates. Erin has worked for them as a senior technology advisor, and has a lot of interesting observations about DevOps and what that can bring to the table. So, Erin?
Thanks,
The
Robert.
stage is yours.
Okay.
Okay.
Thanks, Robert, and thanks to the folks at MindCentric for co-hosting, and also tip of the hat to, oops, is my mic on?
Yeah, it's not going to broadcast.
Oh, it's only to the camera. Okay, well then I'll speak a little bit louder. Thanks for the heads up. Thanks to MindCentric for jointly hosting today. Also, tip of the hat to my colleague Steve Bogdan, who's here, and I point him out because my goal here, is to give a relatively short presentation and to hopefully have some of you think this could be the beginning of a conversation, because DevOps represents really the future of where operations of software and applications is going. And so maybe a few of us will end up working together. Obviously, our company, FP Complete, offers services around DevOps and other types of advanced engineering things in a collaborative way. So hopefully today's talk is interesting enough that, that there's some questions after, and that some people want to have another conversation another day. And in the meantime, hopefully it's at least as interesting as the beer and food. So with DevOps, we do love these diagrams. We do love to talk about how things overlap and connect. And this is another way of breaking into 3 parts what it is that I think we're all trying to do. We're all trying to deliver with IT all kinds of new features to our users that let them get their work done quicker and sometimes soon. And we're never done, because whatever we do for our users, they want more. So in IT, we're looking for a lot of productivity. We have a lot of customers. There's always a backlog. I mean, we actually use often the word backlog to describe our to-do list. That's how accustomed we are to being backed up with demands that need to be met. But we're also looking for quality. We're also trying to deliver solutions that actually work, that don't crash on Monday afternoon and make you think your career is in jeopardy. Because it's not good enough to have something that runs 90% of the time and then either crashes or loses user data, or that can't be shipped because it never even passed its own tests. So how do you merge productivity and quality in IT? That's a hard problem, and it gets even harder when the demands go up and people say, well, I want performance, I want throughput, I want a system that's going to scale up as my business grows. So don't use some tool that's going to build me a bad piece of software that's going to work today, but it's not going to work tomorrow. So the constraints on us as IT and technology people in general are very, very strong. And I would suggest that, that it needs help, and that's why we're going to talk about DevOps today. Just a moment about me, just so you can decide if I'm qualified to talk about this. Obviously a lot of gray hair, been doing this for a long time. I was one of the designers of the distributed systems and networking stuff that's inside of Windows and inside of Microsoft Exchange. I was the architect of the server side of MSN, Microsoft's family of online services, when it first launched onto the internet. So I designed the sort of how their data centers would be structured from a software point of view. I served for a while as Bill Gates' senior technology advisor when he was CEO of Microsoft, back when computers were a little bit smaller and it was a little bit harder to get them to do things. I've gone on to run what was at the time the world's leading software development tool, Visual C++ and Visual Studio, where I was one of the general managers of Microsoft's overall developer tools division. And then I built and ran Microsoft's in-house sort of secret weapons team called the Productivity Tools team that was all about how do we get our work done more productively through better technology. And the theme you'll see in my talk today is, this isn't a talk about we should all stay at work longer. This is a talk about if we use better methods and better technology, our work is actually going to be successful. And that's what I've done for my career for a long time. I went on to be CTO of various startups, most recently a local firm here that does secure election services called Everyone Counts. And in 2012, I started FP Complete, as Robert described, to try to advance the state of the art in how we're all doing our software-related and IT projects. So how are we doing? Well, if we stop and notice, I'm going to suggest we're doing fairly poorly. As an industry, not just any specific person, there's something wrong with how we're doing software and IT. Everybody feels like Homer Simpson here. It's frustrating doing IT, right? And it's even more frustrating to our users who can't understand why we can't get them the features they want, or why it won't work reliably and securely and meet their needs. And they're not really interested anymore in hearing our tales of heroics. When we say, I was here till midnight making the server work, the right answer anymore isn't, oh, thank you, for working so hard. It's, well, what's wrong with you? Why can't you make our IT so that it isn't like that anymore, right? If the guy who built your house said, I was here till midnight fixing the leaky pipes, you wouldn't say, good job, thanks for working so hard. You'd say, come up with a better way to make pipes. So we've got to get out of this mode of constant fire drills and coping and figure out a way to get our information technology back to actually doing things for our organizations. The reason we've been coping for far too long is that our technology is not caught up to how the world really works. And in particular, software is not designed for how modern servers and networks and production environments really work. If you look at how software is made, whether you got it from somebody else or you're making it yourself in-house, we often make software on very small computers And then at the very end, when it all seems to be working, we say, oh, by the way, there's this completely different environment where we actually run our company. So we'll just copy the software over there, and it's going to work, right? Well, it doesn't. It doesn't work. And so we have all kinds of failures. I like to use the word reproducibility from the life sciences and healthcare industry, right? If you have something not reproducible, it means you can't prove that it's going to work, because every time you do it, it's different and done by hand. But we have irreproducible servers because somebody really smart, probably somebody in this room or somebody who works for somebody in this room, is waving their magic wand to somehow get the apps to work on the complicated networks of computers and other devices that are our production systems. They don't work, and depending on who typed the command, they might have typed it differently. Something is different one day. I was just over at the Global Air Show in Paris. There's an amazing aircraft called the A400M. It's a 4-engine military craft, and it has computers in every engine. And one of them recently fell out of the sky and killed everybody because the guy who deployed the software update onto the engines did it by hand. And he forgot a command that one day, and so the config files that tell the engine how much gas it needs were missing. And so the engines all idled in the middle of the flight and couldn't be convinced that they didn't have enough gas. So the plane turned its own engines off and fell from the sky. That sort of problem happens because there's no reproducible system for putting software from our dev environment onto our production systems. Unfortunately, those production systems were inside of engines and not just at a place where we could all go get a coffee while somebody fixes it. But we can't all get a coffee while somebody fixes our company. If everything does go down on a Monday afternoon and you can't get it back up, it's not interesting anymore to say, well, we worked hard and we tried. Our technology doesn't work, and we've been coping for too long. But I'm going to suggest that since our industry isn't dead at this point, somebody must have solved this problem. How is it that the internet keeps moving forward and software as a service keeps moving forward and software products keep coming out? There's every reason to believe that somebody must not have their business falling from the sky the way that airplane did. Somebody must have figured out the problems with IT, and how can we learn from that? Well, I'm going to Sherlock Holmes this up and show you some data and just let you read this slide to yourself for a second. Did you get to the bottom? There's something going on, right? I don't have to be too big a genius to say that right about here at Software as a Service Startup, there's a dividing line. And there's a generation of companies that have figured something out about how to deploy software where they can put new software into production whenever they want. And they're very successful companies. And then there's sort of all the rest of us putting software into production at very long intervals. So evidently, these people have technology that these people haven't yet got their hands on or put into production. What is that technology? That technology is DevOps. And I'm here today to really say, if we can adopt those better tools, we're going to be okay. In fact, we're going to do very well indeed. And the reason is, when you put new tools into production, your whole industry, your whole enterprise changes. Think of a factory that makes something out of wood, maybe chairs, and this is the tool that they have. This is what a lot of our work is like today. We have very smart, very skilled people. We give them the sharpest saw in the toolbox, and we say, you use your skills and you're going to make a great piece of furniture. That's true. That's true. But not a lot of furniture is going to come out, and that person better be pretty darn smart. Also, the chairs are probably all going to look different from one another. A modern tool doesn't look like that. It looks at least like a power tool that has some settings and some gears in it. And if you set this saw to the right angle and you pull down on that handle, you're going to get a reliable cut of wood the same time every time. That's a tool from the 1970s. But a really modern tool looks like this, a computerized cutting machine, where you program in what you want. And what you'll see on a tool like this is it's fast, it can do things as many times as you want, and it never makes a mistake, and it builds in the process of cutting. The other thing you'll see in a tool like this is the actual part that does the cutting is almost all of this tool. There it is on this tool. It's a couple of pixels. The part that does the cutting is the easy part. We as a civilization solved the problem of how to cut a piece of wood some time ago. The hard problem is directing that cutting to where you want it to go. And the same, as you'll see in a couple minutes, is true with software. We know how to write applications. Programming isn't that hard anymore. It's getting them to work. at the right place, the right time, the right way. That's hard, and that's what DevOps is about. So you can't just try harder. All you'll do is cut more pieces of wood. We need to try better. As you saw in the very first slide today from MindCentrics, we believe that DevOps is about combining the creation of new capabilities, developing apps, building whatever IT systems you want to build, with some kind of an integration thing I've called deployment in here, so that the software ends up in an operating environment ready to operate every day. So DevOps is about turning IT into a factory, a productive, automated factory that can move new capabilities from a developer's desk or from wherever you got the new software all the way over to your production environment. How do we do that? The same as we do with a cutting table, by taking that little nugget of goodness, which for us is the application, and surrounding it with much more automation and much more technology. So we're not going to read this slide, but this is how much more technology I'm talking about. In this diagram, which is a typical FP Complete DevOps deployment, where does the app live? It's inside this box, and the source code is inside this box. Everything else in this whole picture is DevOps. This is all about surrounding an application with infrastructure that allows it to be built and deployed and operated successfully. We're not going to walk through this diagram, although you all get copies of it, but obviously there's a lot of very specific tools that we would use in a typical deployment. This is a Linux and open source version of the deployment. Where are all these tools coming from? Is this going to be super hard now? No, it's not. In fact, with thanks to GrowthPoint, this is a diagram of some of the companies that are producing DevOps tools right now. There is an abundance of great tools now for doing DevOps. Company after company agrees that this is a crucial problem area that we need to work on. Our belief at FP Complete is that it's our job to be experts at this technology and then to partner with other companies that have their own in-house IT capability, but that don't want to have to figure this all out from scratch. That's why we exist as a company. As a boutique engineering firm, our role to some degree is technology transfer, to come in and say, let's get you set up on a better way of doing things that will allow your whole team to go forward more productively. So it's our job to know about these things. But my point in showing you this slide is really to say there is an abundance of great tools in DevOps. There's a reason why those companies at the bottom of my previous slide can get apps deployed every few seconds. And that software is available to all of us to automate how we deploy new applications and solutions onto our production data centers and servers. What are we trying to automate when I say we're automating? A few different things. First, we can completely automate with private clouds or public clouds the creation of infrastructure. The day is gone when you should have to figure out how many servers you're going to need and what type of devices you're going to need and how much storage and networking capacity. Cloud with virtual machines and so on gives us the ability to automate that, but automating isn't the same thing as having a command line available to you. Automating is using modern DevOps tools to declare what your application needs and have a script run whenever you need more servers so that you can, or whatever infrastructure you need, routers, you name it, VPCs, virtual private clouds. So we want to automate the creation of IT infrastructure. That's called infrastructure as code. A script or a declarative statement about what you need should be able to run, hook up with your cloud provider, and automatically bring up the resources your application needs. That's an important part of DevOps. We also want to automate the building of software. Some of you are familiar with the term continuous integration. That means having a system that's online and running all the time that will bring in new source code whenever you or someone in your company modifies it with approval, build a new version of the software, automatically test it, and automatically make it available for deployment onto new machines. Containerization is a technology you're going to hear a lot about in the next few years. If you're not already using containerization, there's a good chance you will be. Containerization is a technology for grouping together applications and the other files that they depend on and creating an identical configuration with all those files that looks the same on the developer's desktop, on the test machine, and on the production machine. So continuous integration in its more advanced sense is about having a server that automatically builds new versions of your apps, puts them into a container that's ready to deploy, whether onto your laptop or onto a much bigger production system. As an overview talk, I'll leave that at there, but we can talk more about any of these topics going forward. We also want to automate the actual running system. Once you have an application that's deployed and running, we want to automate the management of it, and I'd particularly draw your attention to things like capacity on demand. At FP Complete, we've been running systems online for the past 4 years that run completely unattended on the cloud, and when too many users get onto the web application, it just fires up another copy. And I don't mean another just copy of the software, I mean it tells the cloud to create an entirely new server, which is built out of physical servers that the cloud provider had on standby. Go get a new server, go put an operating system on it, go put this container on it that has our application on it, and add it to the list that the router is willing to send traffic to. So while applications are in production, there should never be a time when somebody's pager goes off saying, we don't have enough capacity and our server is overloaded. There should be a little script that fires off that says, go make more servers. Why has the world changed? Why do we now have tools like this? It all boils down to computers are cheap and we now have virtual machines and clouds. Once those things were invented, all this automation became possible. It was no longer the case that you put somebody in a car and say you have to drive over to the data center or we're never going to have another server. No, your cloud provider can do that for you, and what we do is automate that process. Once we have automation, life gets a lot better. Once you have automation, you can increase the tempo of new releases. You might not want to release every second or every 15 seconds, but once you're releasing new software reliably and predictably every week, life looks completely different from how it used to look in sort of more traditional software development, where you say, well, we're planning a release for 8 months from now, and we'll get as much into that train as we can, and then it's going to leave the station, and then another train will leave the station 10 months after that. Life isn't very good in that mode because everybody tries to put more into that release. And so inevitably that release is gargantuan and unreliable. When you know there's a train leaving the station reliably every week, you don't even need to look at the train schedule anymore. You say we're going to get these features working and they're going to be deployed automatically if the test passes and the next release date happens. So we can increase the tempo of releasing to something where our customers are no longer calling us up and saying, hey, where are my new features? The answer is they'll be on the server within a few days of the developer having them working. That means we can say yes to new features. We can change our job as people in IT and software from saying no because we don't know what the impact will be of adding your feature to yes because we have a stable system with all the latest features in production all the time. So it's very easy to say, well, the impact of your new feature will be very small because each week we just release a few little features. It also means, this is a technical thing we'll get into if we have time, that you can lock down running systems completely. Once you have a cloud-based automated deployment system, you can eliminate the step of modifying and correcting your servers once they're in production. Instead, you can have what are called immutable servers, meaning that the server is set up by an automated script. That script runs, your server has on it whatever it has, and if you ever want to change anything about the software on that server, you just kill it and make another server. Immutability means your servers are never in an unknown or unprecedented state where you sort of say, oh gosh, what command did that guy use? Oh boy, I'm not sure if my data is secure now. I'm not sure if my servers will talk to each other. Of course they'll talk, because every server is in a state that was generated by a script that's under configuration management and is auditable. That's something you get when you've automated deployment. You get it for free. So you get the ability to audit and control those engineering changes and any administrative actions. You can no longer wonder why. Why did this happen? It means also, once you've automated this, that you're ready to use new cloud features because your system will automatically work on the cloud. And that means that for those of you with a business mind, which is some of you I know, you can move from using capital expenditures, capital expenses, to build servers that are based on detailed forecasts to using operating expenses and saying, I'll just fire up new servers from my day-to-day operational budget whenever I need them. That makes life a lot simpler when you need to be flexible and able to respond to your users' changing demands. So I know we started a little late, so I'll try to be a little fast on the meat here, but I know some of you, this is some of your favorite part. These are some of the things that we physically do when we set up DevOps in an organization in partnership with somebody's IT or engineering department. We automate pieces of the engineering department, we automate pieces of the operations, and sort of, if you will, our favorite spot is the middle, where we build the bridge between these two with what we call deployment automation. I'm not going to talk through all the steps on this slide because obviously there's a lot of them, but we'll make sure you all have copies of this slide, and I'm happy to address anything you see here in more detail given time. We talked about immutable servers, replacing servers with better ones. I made a special slide just to emphasize the importance of this technology. If currently, like most companies, you treat servers as living things that have to be handheld and have to be patched and modified and improved while they run, try to get this mind shift going and see how it feels. Ask yourself, what if I could simply replace any server with a slightly better server anytime I wanted to? What if that were cheap and easy? Wouldn't I do that? So immutable servers are a technology we're going to see a lot of once we have automated deployment. Another thing we're going to see a lot of, another term some of you probably know or have come across, is service-oriented architecture. This is where we take an application and divide it into multiple separate little applications, each of which does a piece of the job, and they talk to each other over application programming interfaces, APIs. What's special about service-oriented architecture is you have completely different servers running different pieces of your application that can be maintained, modified, scaled up separately, and you don't even have to coordinate closely between the teams that manage those different servers. You could just modify one piece of your application while leaving the other piece literally untouched. Service-oriented architecture becomes practical when it becomes easy to deploy lots of servers. Until that time, nobody wants to break your application into 10 servers instead of one because it's hard enough to deploy one server. So again, automation unlocks new software architectures for us that now become feasible. So right away, when we turn on DevOps, there are some immediate wins. We start having faster time to market for our features. The scariness of deployments goes down. That sense of so many companies we've talked to who say, every time we deploy a new piece of software, we sort of grit our teeth and we warn our families, right? We might not be home tonight. And we actually had a company, I'll tell you a micro anecdote. We were talking with a company here in town that's a software as a service company, and they said, we want your help with DevOps and deployments. And we said, well, great, that's what we do. What help would you like in particular to start with? Because we like to do a phased rollout, and I'll talk more about phased rollouts if there's time. And they said, well, okay, we want a way to have a conference call when there's an emergency and there's a failed deployment so everybody can talk about what broke. And I said, we're not in the business of fixing things after they broke on an emergency basis. We're in the business of preventing that from happening. And they said, we're so far deep down this hole where more than once a week we have one of these emergencies where we have to get everyone from engineering and everyone from IT on a conference call that we'd actually like to solve that first. I said, we might not be the right company for you. We'd really rather help you move forward. Life gets a lot better when you have proper DevOps in place. You can correct issues before they hit the server because you can have a new deployment whenever you want, and because your dev environment through automated setup looks the same as your production environment, you're going to find bugs before they go into production. And if, heaven forbid, something goes into production that doesn't look right, it's very easy to automatically roll out another server that works better, maybe roll back to the previous version, for example. By getting dev and ops to think together about how the servers are going to work, we begin to break down the silos that make it so scary to be in IT today, where you say there's only one guy who knows how to set up this server, right? If he or she, that person leaves, there's no other wizard in our company that knows how to make our servers work. We get out of that mode and into a mode of calm collaboration where everyone understands what they're trying to build and operate. And in the longer term, that means we get some strategic wins. Our customers ultimately get more features more often. We no longer feel like we're at risk of getting fired every time we try to do anything. That increases our liberty to put new features into play. We automatically scale up when demand goes up, and we automatically get access to new technologies as they're built into our cloud provider. And ultimately, it's less work to build software the same way. I was talking here in town with a company that makes healthcare software who has implemented full DevOps themselves and does actually have a weekly release cadence. And they've said, everyone goes home for dinner with their families every day. That's the single best thing they said about implementing DevOps. It's not how much better our software is. It's not that our customers are no longer yelling at us. It's that everyone wants to work here because they all get to go home every night knowing that nothing blew up. But it's still hard. You can prepare for resistance when you want to roll out a series of new technologies, even those that are as basic as the ones in DevOps. You can expect that people will resist this change a lot because for years we've had this culture that our job is to be firefighters. Right? For years we've just said, well, we're emergency fixers. That's what we get paid for. Some of you probably know the joke that if you're an IT manager, when everything's working, people say, why do we pay you? And when nothing's working, people say, why do we pay you? Right? So how do you do right as an IT person? Well, historically, our answer has been by fighting fires. What we're trying to do, as we were just talking about before the talk, as John and I were talking about, is we're trying to move you from a world where you're in danger doing the thing that gets you credit. Right? If it doesn't work, you and your company are at serious risk of catastrophic failure. We're going to move you to a world in which you can take credit for things that are safe and reliable. Say the reason you're paying me is all the new features that came online this past 6 months and all the new features that have come online these next 6 months, not because of fighting fires. But there are people who work with you who think their job is emergency. So there are cultural changes to be made. And there are people who will say, well, I learned a tool 3 years ago. I want to get paid forever to just use that tool. So be prepared for some resistance when you actually want to fix things. Not everybody wants what's best for the company. You need to drive that forward with some persistence. And of course, you don't want to, on the other hand, try to do everything at once. You don't want to drive change so quickly the organization can't absorb it. And one of the topics that one of you asked about before I started today was how do you roll out DevOps? And the answer is you don't roll it out all at once. No part of me is suggesting that we should go to anybody's IT organization and replace everything on the first day. The great thing about DevOps, you've seen how many different pieces there are and how many different tool makers there are and how many different stages there are. The way to roll out DevOps is to pick one problem that's really troubling your organization right now, work with somebody who's already fixed that type of problem and say, give us a copy of that fix. Just bring us that piece of technology. Let's do one thing better as an organization. And with that under our belt, let's do another one and another one and another one. There's nothing about DevOps that's monolithic. Automation can be done in as many stages as you like. So trying to do everything at once is what people get too excited. So don't worry, it's not necessary to do everything at once. It's not even recommended to do everything at once. There's a need to bring in knowledge. That's why we're here today. We're sharing knowledge. It's going to be a constant issue for all of our careers that we're always going to have to learn new practices. But still, you'll have people who drag their feet. And then you'll have people who say, well, I could have written that. Right? So what if there's 100 companies and 100 open source projects? I'm smart. I'll write our DevOps system. Please don't fall into that trap. It's really tempting to let technical staff or oneself try to build these solutions again. There's just no benefit, right? We don't write our own word processors either. You'll have the usual issues of people saying, I just don't have time to do anything. Robert was telling me the joke about the guy who says, stop talking to me about that fire extinguisher that you're trying to give me. I'm busy looking for a fire extinguisher. We get a lot of that, right? So people are very, very busy. It's probably the #1 obstacle to adopting DevOps is simply saying, there are so many problems right now, I don't have time to think. That's another reason to break it into small pieces that are easily adopted. You'll find that you need to rethink how things are budgeted, because DevOps is about making investments in software and process. They'll pay for themselves immediately, but somebody's going to have to hear about how the budget works for all that. And of course, you'll have to pick which tools you use, because there are a lot of them. It's another reason why people like us are around, to say, let us help you. We spend all day on these things. So a few takeaways then. I'm going to wrap up, and because we could get more detailed about anything, but I know everybody wants things to say reasonably concise. Automated deployments will change your life. If you do not have a system for automatically deploying new software, new applications, and new updates onto your servers, you need to get one. We're happy to help, of course. Continuous integration will change your life if you're making new software. Having a system that constantly builds and builds and builds new copies of your app and constantly runs the tests. And we could have a whole separate lunch talk just about testing and how important it is to make sure that your software is well made before you put it into production. Again, automation makes that easier. Once you have a reproducible system, your life gets better. So DevOps is ready for you to use, and it will make your life a lot better. And we'll do some Q&A in a minute, and we'll see what people want to hear more about. What I would recommend, since a lot of you are in leadership positions, is put your focus on the right topics. Don't get drawn into questions of, should I use tool A or tool A2 or tool A3? That's not really the main question about DevOps. These tools work very, very well indeed. The question is, can we change our organizational culture and our way of making decisions to learn about the better tools and to make a commitment to adopting better tools and the better processes that go with them so that we can have a calm and orderly cadence or tempo of new releases that are reliable, predictable, and secure. And as you're managing your teams, push them to focus on things that are reliable, things that are predictable, and take the trophies off of the firefighting category and put them into the fire prevention category. Of course, I'm happy to talk more with any of you about any of these topics. It's what FP Complete does for a living. And for now, let's open it up and see if there are a few questions with the group. I'll take a minute to let you gather your questions.
So the service-oriented architecture slide, where do microservices play into this?
Okay, where do microservices play into service-oriented architecture? Two ways. One is that you can break your application into very small pieces, and you can say, there's a piece of my application that other people in my company should be able to access. If I could easily deploy that onto its own little server and publish an API, now no one else in my company has to reinvent this capability. They don't even have to see my source code. And this is where life changes between DevOps and traditional software engineering. In the old days, you'd talk about code sharing. I wrote something, how can I give this code to a colleague who can then put it into their app? In the new days where we talk about dev and ops working together, you never have to show that source code to your colleagues. You can just tell them, hey, I've solved this problem, folks. Here's the address of the server that I and as my engineering people and my ops people are keeping it running all the time. Don't worry about how it's written. Don't worry about the code. We'll maintain it. We'll upgrade it over time. Just connect to this address, and the service is there for you. So that's you taking a piece of your application and publishing it as a microservice for your colleagues. That's one way. The other way microservices factor in is once you have an architecture for your applications that assumes that they're online and can reliably access online resources and cloud resources, you can start shopping for other people's microservices. So you can start saying, why do I have to solve all these problems? And you can shop for smaller and smaller problems that an outside company may have solved. Perhaps you just need user authentication. Perhaps you just need data backup. Perhaps you just need some math done. And you can pick little services and shop for them without having to write that code again yourself. As long as you know you have a reliable way to put your app on the network, one of the next steps is to then start accessing network resources. Another question, anything different topic? Yes, sir.
Can you talk about versioning? I mean, if you output like a version every second,
Yeah.
is that in your practice an issue?
Versioning and how do we manage when there are a lot of versions? So there are at least two ways that I would address that. I guess I have two answers for everything, it would seem. Let me talk first about source control and auditing, and then about how do we bring up new versions of software. So for version management, the most important thing is to understand what piece of software is actually on a server, because you want to be able to predict what happened, and if a bug occurs or a complaint, you want to know what software is on that server. We can spend I won't get into full detail on versioning because it's a complicated topic, but my short answer to that would be you want to have an automated system that creates lots of log files. So we did a system, for example, for a big pharmaceutical company where they said the FDA, our regulator, wants to know anytime anything that comes out of this computer looks suspicious. Is there something wrong with this computer? And so what we did is we set up a system of progressive log files where they can go to a server and say, which server answered this HTTP request? What software was on that server? And they can go through log files and back up the question and say, well, which automated distribution action caused that software to get on this server? And when that distribution script ran, where did it get its executable code? And when that code was built, where did it get its source files? When those source files were built, where did those check-ins come from? And when those check-ins were done, what line and what spec was cited by the developer? who checked in that piece of code. So that there's a complete path backwards from I saw this on my user interface all the way back to there was a line in a requirements spec that a developer was trying to implement. And that's why you saw that code on that server. So we can find any mistake that might have happened and trace it at micro version level. Another way I want to address versions for a second is how do you actually deploy new versions of software? I said it's automated. That sounds lovely, but I went rather quickly and didn't go into a lot of detail. There are a couple of main ways that people deploy new versions of applications with modern DevOps. I'll call them immutable device and immutable server. An immutable device means you bring up an entirely new virtual private cloud. Your script says, I know how to build the routers, I know how to build the admin accounts, I know how to build the connections between the machines, the database connections and things like that. I'll just bring up, we did a device, a software-based device on the cloud for one company that when you run when you type sort of go and say, go ahead and set me up a copy of this device, it brings up 12 computers. And so we just bring up an entirely new system and an entirely new virtual private cloud so that versioning happens for the whole device at once. That's a super rock solid way to do things. It's also pretty hardcore. We had as a hardcore client that wanted that level of robustness. But more common is to do staging where you replace the application servers one by one from the previous version to the new version. Two terms you may see in literature about this are canary deployments and blue-green deployments. A canary deployment basically means I have a replicated set of application servers. I'm going to add to that cluster one server running my new version. And then I'll let traffic go to all of these servers and see if anything looks different from the new server than the old server. And if everything looks fine, then I feel comfortable that my new server works and I can roll out more of them. That's a canary deployment. It comes from the expression, the canary in the coal mine, the animal that if it gets sick, you know something was wrong. And then a version of that, another version of this called blue-green deployments, where we say we have two groups of servers, which we arbitrarily call the blue group and the green group. And we'll keep them all running. And today, production's on the blue group. And when it's time for our deployment, we'll put the new software on the green group. And then we'll switch the traffic over. But the blue group is still there until next week's deployment with the old versions of the software. So you have the current and the previous version of your application running in both of these models. So that's a way to handle gracefully the transition, and then you let the network direct traffic, whether to the servers running the old version, the servers running the new version, or both. I know there's a lot more to say about version management, but I'll leave it at that for now. Another question, another topic.
Talk about the trend between microservices and containers. When and where are they applicable?
Okay, so I'll focus a little bit more on containers, if that's okay, since we already spoke about microservices. But containers are a technology that we use almost constantly. First of all, just a show of hands, how many people here have any familiarity with containers or containerization or Docker? Okay, so about a third of people. So I'll explain a little bit. So containers are a technology that's much lighter weight than virtual machines, but it's a technology for grouping together all the resources needed to run a particular application and its particular runtime environment. Because a container is not a whole virtual machine, you can actually deploy several containers onto one virtual machine, and therefore microservices become more feasible. You don't need to set up separate virtual machines for every application that has its own preferences for its runtime environment. The container brings with it config files and even operating system related files that it wanted to see, effectively creating a little private district within the operating system that's configured as it would want, and those files are hidden from everybody else except that application. So what we're doing with containers is we're saying we like virtual machines. We like the idea of creating an environment on demand that runs whatever we want. But wouldn't it be great if there were something even lighter weight where we could just instantly put new software onto any number of virtual machines? And like with VMs, there are broker middleware pieces of software where you can say, I've put up several copies of this container running on different virtual machines or different physical machines. Please direct the network traffic to any of them that happens to be free. So containers and virtual machines both give us a sense of load balancing and a sense of automatic capacity management where we can bring up more copies anytime we want to. The big difference is containers are so lightweight and so cheap to fire up, even cheaper than virtual machines, that it becomes more realistic to say, I'm going to make a separate container for everything. I don't have to just make very large ones. I can make several small containers. They're cheap, and that's why microservices become even more cost effective. That's different, again, from serverless computing, which is sort of an interesting twist where you say, I don't want to know what server is running this container. I'll just specify, somebody run this container, please, and I'll rely on my hosting provider to find a suitable computer without telling me about it. Does that make sense?
Yes.
Sure, you're very welcome. Different question. Yes.
I don't know if this is a easy question to answer, but when you engage with a client, do you have a typical ROI that the company will experience with the project?
What type of ROI can people expect from deploying DevOps? I'll tell you, the truth is that we don't usually measure it that way because the client usually takes the savings and turns them back into other benefits. So they're saving a lot of money, but they're usually saying, now we can ship instead of not being able to ship, or now we can add those features that we were never able to add, or now we're getting no security outages. So it would be great for me, as promoting something, to have a dollar figure, but what's the dollar figure for not compromising your HIPAA data? Is it $1 million? I mean, what's it worth to not sort of ruin your privacy of your client's data? What's the dollar value in getting your features out this year instead of next year? It really depends on the business what the dollar value is, but people tend to roll those savings back into more IT capacity rather than giving the money back to the corporate treasury. So we don't see it as dollars so much as we see it as IT works ever so much better than it used to. Does that make sense?
Yep.
You measure it in the output of work.
You measure it in the output of work, thank you. And that's not always dollar priced. There was another question over here, I think. Yes, I'm sorry, you're chewing. There will be another question in a moment.
Don't be rude. So, would you mind vamping a little bit more on sort of the serverless environment, where you see it going, the languages involved, particularly? It seems like Java isn't very efficient on serverless.
Yeah.
A lot of JavaScript right now. It's a little bit of where you see that going, what direction you see that heading in, and
Okay.
how much you guys are buying in on it.
Okay, so what are we seeing happening with serverless in the future and also with the choice of languages for programming on servers? Is that fair summary?
For serverless.
For serverless specifically, okay. So what we're finding is, first of all, we've entered a world where companies don't want to commit to a single language anymore. The days where people say we're all going to program in one language are really gone. Because we now have programs talking to each other over network interfaces, you can take any team and say, build your piece using the technology most suitable. And of course, that started years ago where we said, well, the web browser can only run JavaScript, but we don't really want to write our server code in JavaScript. So we had this sort of two language. Actually, it started years before that. When I was at Microsoft, we were doing Visual Studio. And we would tell people, well, write your high performance pieces in Visual C++ and write your easy pieces in Visual Basic. So mixed language programming has been going on for a long time. And it's continuing to be more of a thing and more of a thing, but to the point where now people in an IT department don't care what language someone else was using. And I'll just give you a simple example. If you wrote an app right now and called an API to, let's say, get a stock quote off of a stock quote service, do you need to ask what language that stock quote service was implemented in? No, right? You have no interest in knowing that. Just give me a web API spec and tell me how to ask for the information I need. So in terms of the trends we're seeing, people are using a lot more Node.js. People are using a lot more native code. We're seeing a lot, and our favorite language, Haskell, compiles to high-performance parallel native code. We're seeing a lot more parallelization. We're seeing people running up against issues with languages like Python and Ruby, where they're saying it's not giving me the performance that I need anymore, and they're starting to look at languages that are more parallel-friendly. In the Microsoft world, C# continues to be a big success. On the Java virtual machine, frankly, it's a bit of a mess right now. I think we could argue that the people in charge of Java kind of let it sit for a while, and now there's a lot of discord about which languages people should be using on the Java virtual machine. I'll be honest and say we try to work on non-Java virtual machine solutions if we can. The technology is just so much more advanced these days. In terms of how that all affects microservices, I think the main thing is to say when you want to use, or serverless, you also asked about. If you wanted to do serverless computing, that's probably a little more advanced than most people here are doing, but looking toward the future, the ultimate sort of automated deployment is I want software to deploy by magic and I never want to know how it happened. That's serverless. It's not really serverless, it's don't talk to me about the server. For serverless deployment, I'd say the short answer is the less baggage your application needs to run, the lighter weight the container is that your application is in, the more suitable it is for rapid serverless deployment, which is one of the reasons people aren't so much using JVM. But another reason is just raw performance too.
Well, cost.
Cost.
We took an $8,000 a month algorithm, moved it to serverless, and went down to 8 cents a month.
You went from $8,000 a month to 8 cents a month by putting your algorithm on serverless. So you were renting
Leveraging an
Okay.
algorithm that
Okay.
was
Oh, I see. And is it because you were having to rent a whole server for something that didn't really need a whole server? Right. So not having to rent all that except moment by moment. Yeah, a lot of, if you look at, and I'll pick on somebody who's not in the room, which isn't nice, but if you look at AWS, since it's just the leading volume cloud provider, you look at how the pricing works, you can pay too much sometimes because you're renting huge chunks of resources. And it's very interesting to think about, am I getting my cloud services from somebody who's going to be flexible and make it priced and available in a way that matches my usage patterns? Amazon, they were there first. That's nice. Their pricing is a little bit chunky compared to what people want sometimes. One more question, maybe? Yes.
I like your point of taking on so many challenges initially when you're moving to DevOps. Is there a particular sort of starting point you recommend for a company that's trying to get into DevOps? What would be sort of easier things to start looking at?
Sure. So how can we get started with DevOps? What's a good starting place without biting off everything? I would say we typically look at either how to get an application onto the cloud using automated deployment and containers. That's a great way to start, right? If you have an application that's not cloud-based, a great project is just get that application moved over to the cloud. And most companies have lots of different applications, so you don't have to pick sort of the scariest one to do first. It could be one that's relatively new or one that's relatively self-contained, and you kind of get your hands into DevOps through that path. Another path that we see a lot of companies asking us to help them with is to start DevOps from the dev side, where they'll say, well, we have a team that's actually writing new code. And if we could automate their work, then it would be a little bit more predictable. And then it wouldn't be such a shock when this crazy thing shows up and they're saying, please put this on a server. That's a nice way to also bridge the gap between ops and dev, because you can start having the conversation from the IT or operations group saying to the developers, well, what do you want? Right? We can expose to you an image of whatever runtime environment your application would like. So now you kind of throw that back on the engineering team, the dev team, and say, you don't get to just produce anything you want and tell us, somehow make that run on your server. On the contrary, you sort of say to the IT group, hey, let's be more structured in our offerings. Let's tell the dev group, if you can put out an automated build, we'll tell you what runtime environment that build needs to target. And if it doesn't make it all the way to that runtime environment, then I guess it wasn't ready to deploy. So let's work together and make that happen. So those are two different great ways to get started, getting onto the cloud or getting the flow automated from dev to production for one application. Do we have time for one more question, Robert?
We're over.
Okay. We'll stop there then. And if anybody wants to talk more after, first of all, I'm available. And secondly, I'll move this glass out of the projector's way so you can see my email address is aaron@fpcomplete.com. And of course, you're welcome to contact me anytime. Back to you, Robert.
Thank you, Erin. So just to conclude here, I know the meals got out a little late. Dessert's coming as well. Feel free to hang around. There is a beer menu in front of you. I'm not sure if you had an opportunity to try a Ballast Point beer, but they're there for you as well. But if anybody needs to contact us, we're here now. You can come pick up our business cards, and we're happy to help. MindCentric, I want to thank those folks for co-sponsoring this event with us, and hopefully we'll do some more. So in the future, if you have other people that you think would be interested, we'd certainly like to host them as well. So I'd like to thank everybody for coming out. Thank you.